Good morning everyone. Today I'm giving the presentation of the computer mathematics and statistics. So this is my final project. So my final project contains of 3 questions. So for the first question, we are considering following the two system of complex equations. So by writing the z equal to xyi, we need to solve the equation using the Gauss-Seidel iteration method using the Microsoft Excel until it covers to the 5 decimal. So at first we need to apply the metric equation into these two equations. So at first we can get 2 plus 2i z1 plus negative 1 plus 2i z2 equal to 1 minus 4i. So for the second one is negative 3i z1 plus 3 minus 2i z2 equal to 2 plus 4i. So at the end we will obtain the z1 and z2. We can divide from each to get this value. So for the z1 is equal to 1 minus 4i minus bracket minus 1 plus 2i z2 divide by 2 plus 2i. So for the z2 equal to 2 plus 4i minus negative 3i times z1 divided by 3 minus 2i. So in order to obtain the iteration, so actually we need to build an Excel. So at first we will give an iteration with the z1 and z2. So for the z1 and z2, we will using the formula for the this obtain the z1. So for the z1 we will use IM divider bracket equal to IM sum equal to the imaginary the number you will put in the data. So we later repeat introduce equal to the second part of the data, then we put in the box. So at the end the iteration will be done to obtain the z1, then we will substitute into the z2. For the z2 formula we will obtain the result from the z1, then we will substitute inside. So for this part we will divide into the real number and imaginary number. So at the end this is a percentage of error, so we will from this. So at the end from the iteration we do until 60, actually until 40, 50, 60 we will obtain the constant number for this value. So at the end we will get for the z1 and z2. z1 we will obtain for the 2 minus 3i, then the z2 equal to 1 plus 4i. So in order to obtain the real number, we can using the inverse MS formula. So at the end we will obtain the z1 equal to 3.6055, then for the z2 will become 4.2311. So for the question 2, the question 2 is determine the intersection for the two following equation. So we will get the gs equal to 6 power of 6, s power of 6, hs equal to s plus 1. So in this we will using the two method, which one is the force position method and then one is a Newton-Raphson method. So from we using the range from the 1 to 1.5 to perform a calculation until it converge. So also each iteration we will try to get the exact value to s go to 1.1342. So first we will combine these two equations first. So at the end we will get the fx equal to s6 power of 6 minus s minus 1. So by using the force position method, at first we will be using this formula. So equal to xr equal to xu minus function fxu, then xi minus xu, then the function fi minus f function fu, the xu. So at the end this one is the table to combine we will use in Excel. So for the xi we will use the function from the si. So for the si we will using the is power 6 minus x minus 1. So for the fxu we will using the power s power of 6, then minus s or minus 1. Then we will obtain for the xr. So for the XR we will obtain from this formula also. At the end we will get uh, the actual value and the actual possible error for this one. So at the end we will get very close to the 1.3472. So if you exactly show this 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 answer is correct, since the possible and the accurate error is solution is as this one, equal to 1.13472. For the Newton-Raphson method, so for the Newton-Raphson method, we are using the other formula, so equal to xr equal to xi minus function xi equal to function integration of xi. So for this one, we need to obtain the fxi. fxi we are using the formula of this s power 6 minus s minus 1. Yeah, then for the function integration for fxi we are using the 6 times s power 5 minus 1. So at the end we will get to the xr. So xr we will substitute to this xi again. So actually we will continue calculating. So for the calculating, at the end you also get the same value, so to go to 1.13472. So we can assume the approximate and accurate error for this actual solution s is equal to 1.13472. Next, for the question 3. The question 3 with there's the examiner result course caught by the this lecture. So we will get the data from the three different processor A, processor B, and processor C. So at first we need to plan how the distribution for this analysis. So at first we will assumption for the grade policy is a normal distribution. So for the normal distribution is a symmetrical bell-shaped curve that describe all the data and distribute around the central value of our mean. But some of the student will off a range, but this could be very less compare. So for the grade system, I will using the system. So I will get the A equal to 90 and above, A minus equal to 85 to 89, B plus equal to 80 to 84, B from 70 to 79, then B minus is 65 to 69, for C plus equal to 60 to 64, then C will be 50 to 55, then C minus will be 45 to 49, then the D minus will be 40 to 44, then D will be 35 to 39, D minus will be 30 to 34. So the below 30 will be considered as F, fail. However, the range for this one I will set as a constant for this each. So for the first question, actually we need to find the average mark for the each class session. So actually we will, for the each class, we will average take a total student mark class professor A divide by the total student class professor A. So at the end we will get the 65.932443. So for the class professor B, we also doing the same things. So we will take the total student marks class professor B divide by the total student class professor B. Then we will get the 1.13415. Then for the class professor C, the total student mark class professor C will divide by total student class professor C. So we at the end we will get the 55.06442. So for the question B, we need to construct a distribution mark table for each session. So I will take a grade for calculate how many students we should get the grade A, A minus B minus and until to the F. So for we have the three class. This is three show the table of the grade of student get for each. Yeah, same you can get Professor A have 74 student, then Professor B have 123, then for the Professor C have 107 student. So based on the I above we can build a hypothesis to prove the distribution mark is a fair distribution or is unfair. So we will put a hash now as the distribution mark for each professional class is fair and consistent. Then for the H1 we will get a distribution mark for each class is not fair and not consistent. So eventually we can get the graph table from these three different classes. So at the end we will see the distribution given by the Professor A and Professor B is does not really match the standardized grade distribution such because there are some grading may be unfair and or inconsistent compared to the standard expectation. Since the Professor C has slightly more lenient than Professor A because Professor A had expected high grade in B plus, so it's expectedly highest compared to, and there is a low grade in the C and C plus. So at the end we will conclude that the A and C is accept the fair it is a fair distribution which is accept the H now. Then for the B is reject the H now. So for the type range of this distribution, so the type range of the variable is available. So as a mark scaling for each class is standard and it's the same. Yeah, so for the E, we will combine the three table above to construct a standardized table for the whole three session. So we will combine the Professor A, class Professor A, class Professor B, and Professor C. So at the end we will get the standardized grade for the each total class. So for the total class we have 304 students. So this is the grade for the three total class. So firstly we need to get the average mark. The average mark is a total student marks divided by total students. So at the end we will get the 63.40296. Then for the grade system, as the grade we will set as the same as previously because we don't want to change the grade for this system. So for the number 3 we will compare the percentage of grade for each session with the standardized accumulated table. So we will compare between the Professor A, Professor B, and Professor C with the total number of standard grade for all students. So actually we can see the data is quite rough compared to the system. So it's a system it's quite the percentage for each student to get a certain grade is different from the combination for all professors. So from the data above, we can build a hypothesis to prove a selective range for grade fair distribution as compared to the each session regarding to policy. So for this one, for the H now we will set as the distribution mark of total 3 processor class is fair and consistent. So for the H1, the distribution mark for the 3 processor class is not fair and not consistent. However, from the graph we obtained from the accumulative standard grade of the student, we can obtain the distribution grade is or total is also match the standards also match the standardized, because the standardized grade distribution for the total student grade be expected higher. So this one is a not normal distribution table. So lastly, in my opinion, is it fair to implement the standardized grading policy compared to the individual regarding policy? For me, I think the standardized regarding policy is unfair compared to the individual grading policy. Seen from the different class have different number of students. In Professor A class have 74 students, Professor B class have 123 students, and Professor C have 107 students. The number in grade will be different and cause inconsistency of the grade, since the means and the standard variation of each class is also different. So it's quite hard to standardize the grade for each student. Furthermore, the the different case used for the range grade is also different. So for example, the example class professor class B average grade will fall at B. So this, I think this is policy is not standardized. It's not fair to implement the standardized grading for the this policy. This is all from me. Thank you.